what we've done so far is we've looked at linear sequences, and what we're going to do next is we're going to look at quadratic sequences. So with sequence and series or patterns, whichever way you want to view it, what we've looked at so far is linear sequences or arithmetic sequences, and what we're going to look at next is quadratic sequences. Now, the important thing to know at the minute is what we have come up with. So, linear sequences. What we found from linear sequences is that the first difference is constant. And what we mean by that is that we've got the same, so let's just say we had 4, 7, 10, 13, and so on. The first difference was plus 3, plus 3, and plus 3. So we know that the first difference in each of them there was constant. So now we're going to look at quadratic sequences. And you can see there, the quadratic sequence is this one here. And they're slightly different. So what you'll notice about a quadratic sequence is that the first difference isn't constant. So let's look at the first difference there. Plus 3, plus 5, plus 7, plus 9, and plus 25 plus 11. So you can see here, if we have a linear sequence, the first difference is always constant. That's important. Okay. In a quadratic sequence, the first difference is a constant, but you might notice there that the second difference is constant. So you can see there that from here to here, the second difference is constant. So in a quadratic sequence, the second difference is constant. And we'll just call that the second difference. So the second difference is constant. So that's the main thing. That's the difference between the two. So if you have a linear sequence, the first difference is constant. If you have a quadratic sequence, the second difference is constant. Okay? So it's always just a matter of getting the differences. If the first difference isn't the same, and we can see there it's not the same, then go on and find the second difference. Okay? And that's, we know, the difference between a linear sequence and a quadratic sequence. Just to be sure, so people are aware, linear just means straight line. So a linear represents a straight line. And the reason why it's a linear sequence is because it's increasing by the same amount each time. So think of it in terms of a slope. It's increasing by the same amount each time. Quadratic sequences are U-shaped or N-shaped. And we looked at a full chapter there on quadratics going back, factorizing quadratics and so on. But you'll see quadratics in a small bit, and quadratics are all to do with x squares, aren't they? So quadratics are all to do with x squares. When we look at x squares there, this is the most basic form. So if you think of it in terms of x squared, let's say we took x squared as t of n equals x squared. T of 1 would give us 1 squared, which is 1. T of 2 would give us 2 squared, and 2 squared would give us 2 squared would give us 4, wouldn't it? Okay. So if I put 3 in, 3 squared will give us 9. 4 squared will give us 16. 5 squared will give us 25. 6 squared will give us 36. So you can see there how that's a quadratic sequence. Okay. So for question 1, t of n, they've given you the nth term. They've told you it's a quadratic sequence, but you should know it's a quadratic sequence because you can see the squares. They want you to find the first 4 terms. So I'm just going to do the first one there. So t of n is equal to that. So I need to be able to put in t of 1, which is equal to 1 to be squared plus 4. 1 squared is 1, plus 4 is 5. T of 2 is 2 to be squared plus 4, which is 4 plus 4, which is 8. T of 3 is equal to 3 to be squared is equal to 3 to be squared plus 4, which is 9 plus 4, which is 13. And t of 4 is going to be 4 to be squared plus 4, which is 16 plus 4, which is 20. So the first 4 terms there are going to be 5, 8, 13, and 20, and that sequence will continue on. Okay. Part 2. T of n is equal to n squared minus 2. So t of 1 will be equal to 1 squared minus 2. So if I take 1 and I square it, 1 times 1 is 1. 1 take away 2 leaves me with minus 1. T of 2 will be equal to 2 all to be squared minus 2. So 2 squared is 4. 4 take away 2 leaves me with 2. T of 3 will give me 3 to be squared minus 2. 3 to be squared is 3 times 3, which is 9. 9 take away 2 leaves me with 7. And t of 4 will be equal to 4 to be squared minus 2, which is 16 take away 2, which is 14. So there I'll have a sequence of minus 1, 2, 7, and 14. I'll do part 3. So part 3 is t of n is equal to 2n squared minus 1. So t of 1 will be equal to 2 times 1 to be squared minus 1. And think about that. We always do our indices first. So 1 squared gives me 1 times 1, which is 1. 1 times 2 gives you 2. 2 take away 1 leaves you with 1. T of 2 will be equal to 2 of 2 squared minus 1. Do our indices first. 2 squared gives us 4. 4 times 2 gives us 8. 8 take away 1 leaves us with 7. Do t of 3. 2 times 3 squared minus 1. So indices first. 3 squared is 3 times 3, which is 9. 9 times 2 is 18. 18 take away 1 leaves us with 17. And t of 4 will give us 2 times 4 all to be squared minus 1. So 4 to be squared is going to give us 16. 16 multiplied by 2. So if I've got 16 and 16, let's say I've got 15 and 15. 15 and 15 is 30. So obviously 16 and 16 is going to be 32. 32 take away 1 leaves us with 31. So the first 4 terms of that sequence will be 1, 7, 17, and 31. And that will continue on. Just to be sure, look at our term-to-term rule. Our first difference there, you can see, is plus 6, plus 10, And plus 17 to 20 is 3. 3 plus 10 gives us 30, that's 13. 13 plus 1 is 14. So our term-to-term rule, we can see we're increasing by plus 4 on our second difference. And because our second difference is constant, that tells us that we're using a quadratic sequence. From that, you can also work out what the next term is going to be. So let's just see what the next term would have been. So if I add 4 to 14, I get 18. So if I add 18 to 31, I get 49. So I should get 49 there. And just to make sure we're correct, let's just test t of 5. So if I put 5 in, I get 2 times 5 all to be squared plus 1. Okay, so, or minus 1 even, sorry. So that's just our nth term, same as that. 2 times 5 to be squared minus 1. So that will give us 2 times 5 to be squared. So 5 squared will give us 25. 25 multiplied by 2 will give us 50. And 50 take away 1 will leave us with 49, which is what we worked it out to be. Okay. So that's that one done.